Okay. On chapter 22, we're learning about rounding. And rounding is the way that you do rounding is if you look at a number, like let's say number 1, 39. Okay. It says round to the nearest 10. So we know these are our ones, these are our tens. If it says round to the nearest 10, that means we're trying to see if this number is going to go up or stay the same. Okay, is it 3 going to go up to number 4, or is it just going to stay at 3? Okay, and we look at that by looking at the number next to it, next to its right. Okay, we look at 9, and what we look to see for 9 is we say, okay, is this 5 or more? Is it 5 or more? If the answer is yes, then the 3 goes up. Okay, yes, up. No, stays the same. Okay, so we're going to look at 39. Okay, we're rounding to the nearest 10, so we're looking at 3, and we're saying, does this one go up or down? Well, it's a 9. 9 is 5 or more. Yes, it is, so it's going to go up. So this becomes, 39 becomes 4. And what happens to the number next to it? Does the 9 stay there? No. It just becomes a 0. Okay, so we're rounding to get to the nearest 10. The nearest 10 means there's only 10s in there. Only 10s. Just like when we were separating numbers, we were putting the 1s to the side and the 10s to the side. Over here, we just want the 10s. So when it says round to the nearest 10, this one goes away. Okay, this one, either if it's going to stay the same, if it were to stay the same and not go up, then that would still become a 30, not a 40. I mean, not a 39, but a 40, 30. Okay, so then that one's 40. And then we'll do number 2. That's a perfect example. So 12, okay, and we round that. Okay, remember, we're rounding to the nearest 10. This is the nearest 10. The number next to it, we look to this number and we say, is this 5 or more? No, it's not. So that means this number stays the same. Remember, we just looked to this one. We look to our ones place, or the number next to the one that is going to go up or down that we're rounding to. Okay, we're rounding to the 10s. So we look at the number next to it to decide if it's going to go up or down. But that doesn't mean that this number is the one that's going up or down. We're just using this one to help us figure it out. Okay, so we look to number 1. We say, okay, is 2 5 or more? No, it's not. So that means that number 1, that the 1 is going to stay the same. What happens to the 2? It disappears because we just want the 10s. We just want the 10s. It's rounding to the nearest 10, not 1s, just the nearest 10. Okay? We'll erase that one. And let's do another one. Number 3, 63. Okay? Rounding to the nearest 10. Okay, what does that mean? We look to this number to our right, and we say, is this number 5 or more? No, it's not. 3 is not 5 or more than 5. It's less. So, since the answer is no, then the 6 stays the same. And we put a 0 behind it. Okay? Because we only want the 10. We don't want these ones over here. We don't want those. Okay? So that is how you round. Now, when it says something like this, okay? Round to the nearest 100. It's the same thing. Okay, you are just looking at the number next to it. So when it says round to the nearest 100, underline your 100 so you know which number has to be changed or stay the same. Which one is going to stay the same or which one's going to be changed? Which one's going to go up 1 or stay the same? It's the 3. So then we go and look to the number next to it. Is this 5 or more? Yes, it is 5 or more. So this one goes up. And the numbers behind it just become zeros. Okay? Remember, we only want the 100, so that's why all of these just become zeros, because we only want the 100. We're rounding to the nearest 100. Okay? We'll do another 100. Okay. This one, number 8. Okay? Is 209. Okay, it says round to the nearest 100. This is the hundreds place. We look to our right and we see a 0. Is that 5 or more? No, it's not. So this number will stay the same, and the ones behind it become zeros. Okay? So that's how we do our rounding. I'll do 1,000, one of the thousands ones too. We'll do number 11, 2,154. Okay? So this one, it says round to the nearest thousand. Okay? This is the 1,000. Now we look to the number next to our right, and it's a 1. Is that 5 or more? No, it's not. So that means this number is not going to change. Okay? It's going to stay at 2, and then we just put the zeros behind it for these different place values. 3 zeros behind it because there's 3 numbers behind it, and we only want the thousands place. Remember, if it's 5 or more, then the number goes up. If it's less than 5, it stays the same. Okay? Okay. Then we come here, and okay, over here it's having them do rounding first, okay? And once you round, then you multiply, okay? So you have to do both. You can you solve without rounding, but then you also round to the side and multiply that way as well. So you can do, for example, number 17, 351 times 3. Okay, you can solve it like this. This is 3 times 1 is 3. Then 3 times 5 is 15. So we put our 5 here, carry our 1. Then we have 3 times 3 is 9, plus 1 is 10. Okay, that's what we have. But then when we round it, and what does it say? It says round the top number to the nearest 100. Okay, so this is to the nearest 100. So we look at our hundreds place. We have a 3 here. We look next to our right and we see a 5. Is this 5 or more? Yes, it's 5 or more. It's actually exactly 5. So this number goes up to 4. And then these become zeros. And then we bring over the times 3 and we multiply. 3 times 0 is 0. 3 times 0 is 0 again. And 3 times 4 is 12. Okay? So that's how we do those. Estimate first. And remember, there's a lot of problems that are, they're going to ask you to estimate first in these word problems. So make sure that you're paying attention. Okay, if it says estimate how many cars, if you see this word estimate, that means you have to estimate first. If it says estimate how many cars in all, if there were 26 cars in a row, it doesn't tell you round to the nearest tens. But you know that if there's only 2-digit numbers, that's what you're going to estimate to, is to the nearest 10, because there's only 2 numbers to look at. And the one all the way to the left is the 2, which is the 10th place. And then the one to its right is the 6. So that's the only way you can estimate. Okay, so when it's a 2-digit number, you know that they're asking you to estimate to the 10th place. Okay. Okay, this is more of the same stuff. Yeah, so there's a lot of estimating, so make sure that you estimate before you solve. And the ones that say it, they don't say it, then you don't have to do it. But if they say estimate, then you do have to estimate before you go ahead and solve them. Okay. A lot of these look kind of just like a lot of review, but I will do some of these word problems. I'm going to do number 19. It says a round trip to Grandma's house is 24 miles. Estimate how many miles Jill traveled if she went to Grandma's house and back 5 times. So if she went to Grandma's house, okay, This is Jill's house. This is Grandma's house. If she went to Grandma's house and back 5 times, then that means that she really did go 10 times. So a round trip, it says a round trip to Grandma's house is 24 miles. Okay. Estimate how many miles Jill traveled if she went to Grandma's house and back 5 times. Okay. So if we're going to do that, then we have to do 24 times 5. Okay, she went 5 times. Okay. Because that's going back and forth. A round trip is back and forth. And then it says 5 times. So this is what the problem would be set up if we were not estimating. But this one says estimate. So we have to estimate this top number. And we look at the tens place. There's a 2. We look next to our right. And there's a 4. Is that 5 or more? No, it's not. So this number stays the same, because this is not 5 or more, and then the 4 just becomes a 0, because we're only looking for the tens, not the ones. Okay, then we just move this over times 5, and then we can solve. 5 times 0 is 0. 5 times 2 is 10. So it's 100. That's the estimation. Okay, so make sure you do that step. Do this step of estimating before you solve. Okay, if it says to estimate, 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 make sure you do that first. Okay. Okay. Got some problems here that I wanted to go over. Okay, over here, remember, they'll give you some that say estimate, and they'll give you some that do not say estimate. So make sure that you look carefully, read carefully, and know what you're supposed to do. Okay? Okay. So the same thing goes here. They're saying estimate. Okay, this is a 3-digit problem, so I wanted to go over these a little bit more. But it says, okay, it says round the top number to the nearest 100 and estimate the answer. So we're going to do number 7. It's 876 times 3. So on this one, you see, since it's 3 digits, it tells you specifically to estimate to the nearest 100, because now you could have estimated to the nearest 10 or to the 100. You don't know, so they have to specify. When it's only 2 digits, you don't have to specify. You know that they're talking about rounding to the nearest 10. Okay, but over here it tells us round the top number to the nearest 100. So that's what we're going to do. And we look at this number, that's the 100, and we look at the one next to it, and we ask ourselves, is this number 5 or more? And it is. So then this is going to go up 1 to 9. And the numbers behind it become zeros. Okay? And we move over our multiplication sign and our 3, and we go ahead and solve. 3 times 0 is 0. 3 times 0 is 0. And 3 times 9 is 27. So our answer is 2,700. Okay? And there's one more problem that I saw that I wanted to go over. There is, okay, number 20. Okay, number 20 looks like a difficult one, so we'll do that one together. Number 20 says a bucket holds 7 quarts and a pitcher holds 3 quarts. Erica emptied the bucket twice and the pitcher 3 times. Cami emptied the bucket once and the pitcher 6 times. Who poured more water? Okay, so in order to do this, first of all, we have to figure out that we have 2 different girls using 2 different pitchers and buckets to fill things up, okay? To pour water. So we'll go ahead and separate them by what they're doing. So there's Erica here, and then there's Cami on this side. Okay. Okay. So let me scoot that down more. Okay. So we have Erica and Cami. Okay. Then it says Erica emptied the bucket twice. So, and the bucket holds 7 quarts. So we'll do 7 times 2 for Erica. Okay. That's the bucket. She did that twice and it holds 7 quarts. Okay. And the pitcher, okay, the pitcher 3 times she emptied it. So the pitcher is times 3. And it says at the top that the pitcher holds 3 quarts, so we put that there. Okay, so we have all of our equations for Erica. Then we'll go get Cami set up as well. We have Cami, and she emptied the bucket once. Okay, so that's times 1, and the bucket holds 7 quarts. And then the pitcher 6 times. Okay, so times 6, and the pitcher holds 3 quarts. Okay. Who poured more water? Okay, so now we'll start solving. Okay, we'll solve our equations and then add our answers. So when Erica was emptying out the bucket, she did 14 quarts right here. Then when she did the pitcher, she emptied out 9 quarts. So altogether, 9 plus 14 is 23. Okay, so over here, Erica emptied out 23 quarts of water. Then we have Cami, when she was emptying out the bucket, she went ahead and only emptied 1. So that's 7. And then when she was emptying out the pitcher, she went ahead and emptied out 18. So if we add those, that will be 25. So 25 quarts. So when they say, okay, so we did that so far. Now it says at the bottom, who poured more water? Cami poured more water, so we can say Cami poured more water, or poured more. Okay. Now it says, write the amounts as an inequality using less than or greater than. So we can put 23 is less than 25. And that's how we solve that one. That was a lot, so I wanted to do that one because I read it as I was going through the book. I thought, oh, that's a beefy one. Anyway, everything else seems like just more review on what we covered earlier in the chapter. So go ahead and work on this today. I know everybody's having fun with the snow, but make sure you work on this chapter. And I'll see you all on Wednesday. Okay? Thank you.